Hey everyone, today we're going to learn a little bit more about linear functions, and we've already done some of this stuff, so hopefully a lot of this is review, but let's get started. First of all, if we want to graph a function, then if it's in this kind of form, y equals 3x plus 1, we need to plot some points and then connect the line. We know that's a line because there's no x squareds and there's no x's in the exponents or anything like that. So I'm just going to pick some points, and -2, -1, 0, 1, and 2 are always a good start. On this video, you'll always use at least those 5 x values to start. But I need to remember that because I only have an equation, the domain is actually all reals. That's why we connect the dots, because we could have any value or any point in between these dots that I plot. So just to remind you, to plot this or to find the y values for each of these, we're going to plug them into the function, into the x. So I'll just do this first one for you guys. 3 times -2 plus 1 gives us -5, so the y value is -5. When you plug in -1, you get -2, and so on and so forth. So these are my points. I'm going to plot the points. There's -2 coming -5, -2, -1, and those are the 5 points. And then we do need to connect the line, and you want to draw, it's a good idea to draw the arrows at either end to show it keeps on going forever. And you can always check your work by finding a point that your line intersects that and checking to see if it fits in with the table and the equation. So for example, I might see this point down here or that point up there, and that top point is the point 3, 10. If I put that into the table, notice on the right side, my values are increasing by 3 each time. That's the rate of change, also known as the slope. So 3, 10 fits in with the table of values, so I am fairly confident that this is correct. You can also plug 3 into the equation, and you'll see that 3 times 3 plus 1 is 10. Now, some other comments as you're graphing these: make sure you have a ruler or a straight edge to make your line as straight as possible. Don't just freehand it, because then you won't know what other points are in your on your line. So go ahead, and I'll give you a chance to do the one on the right there. All right, now that you've finished it, here is the answer. Again, I'll do the first one for you. You plug in -2, you get out -7, and here are all the y values. And here are the points. And we connect the dots, and the extra point that is in the equation is 3, 3. And there are a lot of other points I could choose. I'm just picking one that happens to be close that I can count. But I could plug in decimals and fractions because the domain is all reals. So I could plug in 1/2 and find out that, oh, when you plug in 1/2, you get out positive 0, actually. Nope. When you plug in 1/2, you get out -2. And so that point is on the function. It's on the line. That's why we connect the dots. All right. There are 3 different kinds of equations for lines. The first is slope-intercept form, and that looks like this over here: y equals mx plus b. I know there are a lot of letters there, but we need to distinguish between these letters, because the first thing that confuses students is they think all 4 of those are variables. That's only partially true. The x and the y are always variables in all these, but those other letters are a type of variable we call a constant. And constants are letters that represent a number. So for example, if you look down here, y equals 3x plus 1, m and b are not in the equation as m and b. Instead, we put numbers in for those, and we call those constants. So the m there represents a specific number. So for a single equation, we will always have a number in place of that. We'll never have an m or a b. For a standard form, x and y are on the same side. You see the variables are there, in this case on the left, and we have 3 constants, a, b, and c. For point slope form, the variables are kind of spread out. There's y on the left there, and then x is inside the parentheses, and the constants are y1, m, and x1. Now, the name of these functions, or these types of linear equations, is important because slope-intercept, there's your definition for constants, numbers that stay the same. Slope-intercept form, we call it that because it tells you what the slope of the line is and what the y-intercept is. So the slope is m, that's the letter we use for slope, and the y-intercept is b. Likewise, for point slope form, the point is x1, y1, and you see x1 and y1 there, and the slope is again m. So we're going to talk more about that in the future, but that's why we call those types of linear equations what we do. So for each of these, we're going to just identify them as slope-intercept form, standard form, or point-slope form, or it might not be a linear equation, and we'll explain why. The first one is standard form, and that's because x and y are on the same side of the graph, or same side of the equal sign. You see 3x plus 2y equals 5, so in this case, 3 is A, 2 is B, and 5 is C. The next one is point-slope form. I know that because I see those parentheses, and I see there's an x inside the parentheses. That means the point is negative 2 comma 4, and the slope is 1/2. And we'll talk more about that in the future too. This third one is slope-intercept form, because that looks, you notice it looks like our first ones that we did, and notice that the y is all by itself, which is really helpful in graphing these. So you're going to find that the first thing we do is we solve for y to get y by itself. All right, go ahead and make a guess on these last ones, and I'll tell you what they are. All right, this next one is slope-intercept form, because the y is by itself. Don't be confused just because I put the y on the other side. The next one is not a linear equation because we have the x squared. In fact, you know what that's called. That's called a quadratic equation. After that, this is again standard form, and I put this in here to trick some people. Notice x and y are on the same side of the equal sign, but it doesn't have to be a plus in between them. If b is negative, you could just say -8 instead, for example here. This next one is also not a linear equation because of the x squared and y squared. And in fact, if you type that into Desmos, it actually makes a circle. This next one is also not a linear equation. The reason for that is because x is in the denominator, so it does not match one of our three forms. This last one, even though it doesn't seem to be an A or a B, x and y are on the same side of the equal sign, so it is standard form. In this case, A is 1 and B is also 1. And you remember, if we have no coefficient in front of a variable, that coefficient, we assume it's 1. All right, what we're going to do is we're going to solve for y and then graph it. The reason we're solving for y first is because that greatly simplifies and speeds up the process of calculating each of these points. Solving for y is a skill that we learned a while back. It's in a standard called solve for the variable. If you need to go back and look up that video, you may, but I'm going to assume that you know how to do that and explain only briefly each of my steps. So first thing we're doing, since we're solving for y, we need to draw a little arrow to y to show that's what we're trying to get by itself. That's what it means to when I say solve for y. We subtract 3x from both sides, and I'm doing that because I'm trying to get y by itself. And the 3x minus 3x is 0, so I'm going to write negative 3x plus 2. Some people want to write 2 minus 3x. That's perfectly fine as well, but I always like writing the variable and coefficient first because that helps me with what the slope is. So I'm going to plot the x values, negative 2 through 2, and find out what the y values are. And here is plugging in negative 2 in the function. We get 6 plus 2, which is 8. And so the output is 8, and I'll go ahead and do the rest of these for you, but you know how to plug those in. Now that I have all those points, just like we did before, we're going to plot the points. Negative 2 comma 8, negative 1 comma 5, 0 comma 2, 1 comma negative 1, and 2 comma negative 4. So you see, it would be very difficult, or a little more difficult for me to graph 3x plus y equals 2, but I am able to graph y equals negative 3x plus 2 when it's in slope-intercept form. Now, I draw the line, use a straight edge, draw the arrows at the end to show it goes on forever. And I want to point out a few things. First of all, notice that the slope, which is m, that's negative 3 in this case, because that's what's being multiplied by x. That slope is negative, so I'm just doing a quick check and making sure, does my graph have a negative slope? Well, yeah, as you're going to the right, the graph, the function, the line is decreasing, so that checks out. Also, notice it's slope-intercept form, so that y-intercept should be 2, and it is. 0, 2 is the y-intercept. You can also see that in the table, 0, 2. Last piece of advice is that you can always graph these on a graphing calculator once you have it in slope-intercept form. You have to have y equals because that's the only way your TI graphing calculator can recognize the equations. However, Desmos recognizes equations in standard form, so feel free to graph it there too, but I would recommend using that as a check for your for your graph rather than graphing it and then just sketching down what you see, because we need to practice the skill of graphing it without a calculator. All right, let's do these last two because this is turning into a very long video. Solve for y. I'm going to subtract 3x from both sides, and then I divide by 2. Now I'm going to split this fraction up. If you forget y, we can do that. Think about what does it mean to add fractions. And I also notice 6 over 2, that can be simplified, so I need to do that. I want to, in this middle here, a lot of students are confused by this when I changed 3x over 2 to 3/2 x. Those are the same thing. If it helps you to see it, x over 1, when you multiply fractions, that's what happens. And so that is my slope-intercept form. I like separating it out like that because then I can see what the y-intercept is and the slope is. So we list our points. I'm going to plug in the values. I plug in -2 and I get out 6. I'm going to plug in -1 in as well and show you what happens. We actually get out a fraction or a decimal. And though I could write that as 9/2 or 4.5, I'm going to write it as 4.5 just because that's easier for me to check on the graph. When you plug in 0, you get 3, and lastly, when you plug in 2, you get 0. Now, when I'm graphing this, I don't like -1, 4.5 and 1, 1.5 as points to graph because I don't have any lines for those 0.5s. So what I'm going to do is I'm only going to graph these 3 points, -2, 6, 0, 3, and 2, 0. And I'm going to connect the line on those and just double check and make sure my other points are in the right place. This helps me be a little more accurate and yeah, just a little more accurate. So you notice when I plot, find out where's the function when x is -1, it is at 4.5, so I'm correct there. So that's another rule when you're graphing these. You don't have to plot every single point that you create from your table. However, every point from your table must be on your line. Let me say that one more time. You don't have to use every point that you get from your table when plotting it, but every point does have to be on your line. If that statement confuses me, you talk to me in class and I can explain it a little more. So let's just find another point that's on there just to double check. I like the point 4, -3 because it's on a nice even ending so I can see exactly where it is. And that point is in the function. All right, last one. I'm going to solve for y. Here we go, solving for y. Divide by 4. I'm going to split the fraction up as before. And 4 over 4 is just 1. So I'm going to simplify that. And I write that -3/4 x plus 1. Now, this is a little bit trickier of a function to plot, and I'm just going to do the first 3 points to show you why. When I plug in -2, I don't get a nice even number. I get 2.5. When I plug in -1, I get an even uglier number. That's 1.75. Ugly in terms of having to graph it. So I'm not going to use either of those numbers, and I need to be more thoughtful about how I approach the next x value to try to plug in. I could plug in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and just use the ones that work, but if I think about it, I can save a lot of time. Why was -2 and -1, why were those ugly values? Well, the reason those were ugly values is because of this divide by 4 right here. 3/4, you have 3 on top, but you have dividing by 4 on the bottom. The only numbers that divide nicely by 4 are multiples of 4. So if I want nice numbers on the y value, I need to pick multiples of 4 on the x. So I'm going to plug in 4 and watch what happens. When I plug in 4, -3/4 times 4 is -3. So -3 plus 1 is -2. That's a nice point to plot. I'm also going to pick 8 and get -5. And I could also plug in 12, or I could plug in -4 as well, just to check my work. It's always a good idea to get at least 3 points, and those are my 3 points. That way, if I messed up on one of them, I can see that and quickly double check those. So I have my 3 points, use your straight edge, and I want to check one more point. That's going to be -4, 4 is the other point that's on there. All right, try this last one on your own, and I will show you how to do it in a moment. All right, here's how you do it. These are the points. Sorry, really, these are just the answers. That way you can stop watching the video and comment on it. All right, thank you very much for watching.